I wanted to start off by saying that telemedicine is a very broad field, and there's a lot of it about already. If you regard it just as conveying medical information to medical practitioners who are geographically distributed, who are some distance away, things like the use of digital X-rays is telemedicine. You know, there was a time in hospitals where X-rays were taken on film, and people ran around hospitals with bits of wet film, wet from the developer and fixer, and they had to be pinned up on the wall. And if they needed a second opinion, the X-ray had to be taken to the other doctor, or they had to fetch the other doctor to the X-ray. These days, almost universally in the health service, it's done with a digital camera, as you would expect. And therefore, the X-ray can be transmitted across the wires to a computer close to the person who needs to interpret it. And it can be done almost instantly after the X-ray's been taken. So you cut out a lot of time, you cut out a lot of money, and you make it very easy because that X-ray is now on file. Your GP can look at it. It's very easy if you go into another hospital, potentially they can get a copy of it and look at it. It makes it very easy for clinicians to see the information that's appropriate. One trivial example, in some parts of the country, prescriptions are no longer written out on pieces of paper. They're transmitted electronically to the chemist. So you can go into a chemist and say, you know, I've just been to this doctor, I've got a prescription, here's my name and address, here's some ID. They can call it up on a computer, say, yes, okay, here's your medicine. And you don't need to be carrying paper around. You don't have all the hassle, the overhead, and the added cost of doing that. In fact, at the moment, the most common telemedicine activities that are going on at the moment, there's probably the highest proportion are second opinions, consultations or second opinions, where you're in a doctor's surgery and you've got some symptoms they're not quite sure about. And whereas what you might be familiar with is a doctor turning to their bookshelf and getting out a textbook and looking something up, now they can actually call up on a screen an expert from somewhere else. You know, perhaps you've been drinking something. Inadvertently, you've swallowed some poison from some household product. And they need advice on what to do. And they can call up the poison centre and actually have a face-to-face conversation over their computer screen with an expert, with you sitting there so that they can ask you questions or carry out particular examinations and get a clear second diagnosis immediately without you having to be rushed off to hospital or taken across the other side of London to a specialist unit. Those sort of things are going on already. There's a lot of remote interpretation of diagnostic tests, and there's quite a lot of remote monitoring already. People who are wearing pacemakers. And the pacemakers can be scanned externally and will be reporting back data that they're recording, so that the doctors can simply check on those things, or so that they can automatically raise alarms if the sensor inside the embedded pacemaker detects that, you know, maybe you're at the start of a heart attack. An automatic alarm can be raised. These things are happening already, and there's no doubt that the increasing use of technology is a terrific benefit to society, to all of us. You know, if we're going to manage to keep up with improving health and keeping the costs down, we've got to exploit these things. But we've got to get the balance right. It's terribly easy, for example, to find that in order to play safe, you're getting people to go and see a doctor after measuring some symptoms, and you're creating more people going to doctors just for checking out something that turns out not to be a problem. because you can't risk, now that you are monitoring them, and therefore you're carrying perhaps some liability if you don't send them to a doctor if they're a bit sick, suddenly there's a problem that actually you're referring too many people and creating more of a strain on the health service than would otherwise have arisen. And medicine is one of these funny areas. People die. People die a lot. Everybody dies once. And except the man wearing the magical immortality bracelet. And under those circumstances, quite often, there is a necessary trade-off in healthcare between how much are we willing to spend to prolong somebody's life that little bit. It's a terribly difficult decision. How many kidney dialysis machines can you buy for the cost of one heart transplant operation, or for buying an MRI scanner for a hospital? How many people will the scanner or the heart transplant operation save compared with the number of people who will now die waiting for a kidney dialysis machine because there isn't one available? These are hard decisions that the health service in every country has to make. And so we need to make trade-offs. Now, I'm an engineer. Why am I here? I'm here for the reason that Nigel was talking about at the beginning, because engineers invent the future that you live in. Everything that has changed in a material way over the last 100, 200 years has been invented and built by engineers. Scientists find out things about the world. Engineers change the world. That's what we do, and I hope it's very exciting and very rewarding. And I hope that a number of the young people here will choose to be engineers, because it is so exciting, and because you are creating the future that you will live in and that your children and your grandchildren will live in. But that means that we need to be talking to the people who will be living in the futures that we're building, because it's your future. You have a stake in it. You must have a voice in it. But if that voice is to be listened to, the things that you say have got to be based on enough of an understanding of what is possible and of the likely consequences of the things that are being suggested as things that could be developed, so that you can actually put forward things that the engineers will listen to and be able to understand and fit into the context of what they're doing and respond to. And that's why it's important for engineers like me to get out and listen to you, and also to tell you the sort of things that I think I've learned in a career that will help you to evaluate the things that other engineers tell you, or the particular dreams that are being put forward as possibilities for the future. Now, I work in computers. My particular engineering background is computer-based systems. And although, as engineers, we know how to build computer-based systems that work, and which we can demonstrate work with very high probability of them continuing to work successfully, in fact, almost nobody in the industry uses those methods. As a consequence, and there are reasons for that, but that's not the subject of the day. We can talk about that over lunch if you like. But the consequence is that almost all computer-based systems contain lots of errors. Typically dozens in a small system, hundreds or thousands in a big system. And so you need to bear in mind, when people are putting forward technical solutions, that you can't show that a system is highly reliable by testing it. You have to do it in different, harder ways than that, and that means that in general there will be faults. That means that, for example, databases will continue to get hacked, just as somebody mentioned earlier on, the Sony PSP database was hacked recently, and so many people's passwords were stolen. And indeed, just last week or the week before, their video database was hacked as well. So they hadn't managed to apply the lesson they'd learnt to one to the other quite in time. So there are issues that need to be recognised about things like security and confidentiality. Microsoft has done some work that has been showing that, for example, even if the information that is transmitted from a pacemaker is coded, encrypted, you can still actually recognise the particular details of the patient despite the encryption. And it's well known that people's ECGs within a small group are actually unique. So you could use that for tracking an individual as they moved around. I can't imagine anybody building the equipment to do it. Why would you want to? But in principle, it could be done. People have discovered that for most of the commercially available things like defibrillators and heart pacemakers, somebody standing next to you with an appropriate receiver can read out patient name, date of birth, diagnosis, and quite a lot of medical information that is stored in those devices. It's an issue. It could probably be prevented by different designs. You need to think about how much you care about these things and be putting pressure at the appropriate times on people to design systems that you feel comfortable with. I wanted to just ground some of this by telling a story about a particular unfortunate incident that occurred probably 15, 20 years ago now, perhaps even a little more, but it's sort of telemedicine. It was a man called Ray Cox, who was an oil worker in America. And he developed a cancer in his shoulder. He'd got a tumour in his shoulder. And it was being treated successfully. There was a radiotherapy system, you know, one of these great big things with a generator of electron beams. You lie on a table and this great arm comes around and focuses a beam exactly on the tumour and is able to burn away the tissue. And you get a number of treatments, and it doesn't feel any great discomfort. There's some warmth, but you know the treatments can be very successful. This particular piece of equipment worked in two different ways. It could be used for taking X-rays, or it could be used with this electron beam for treatment. The electron beam was relatively low power. For X-rays, they turned the power up by a factor of 125 times and put a metal plate in front of it. And the beam hitting the metal plate created the X-rays so that they could use it as an X-ray machine as well. In the first version of this system, if you wanted to switch from treatment mode to X-ray mode, what you did was you swung the metal plate across in front, and only then could you move a mechanical switch, which switched from low beam to high beam. And then they introduced a new version that was all computer controlled, and all that mechanical interlock was taken out and they put it into the software. Now, Ray was being treated, and in the latest version of this system, the operator, who was in a remote room, so it was in a sense telemedicine. The operator couldn't be in the same room because of the radiation risk. If you're treating lots and lots of people every day, you get a build-up of radiation. You want to keep the operators of these machines out in separate rooms. They had a video link to the treatment room, and they had a loudspeaker connection as well. Both of them were broken. The operator typed in the command to set up the low power beam, but got it wrong. And in a period of 8 seconds, backspaced, corrected, typed in the right thing, hit go, and the screen said malfunction. So the operator cleared the error, the machine said beam ready, and it hit the button again, and it said malfunction. They repeated this 3 times. Meanwhile, in the treatment room, Ray got a massive jolt on his shoulder. Not anything that he'd ever experienced before. And then he got 2 more. He yelled in pain, nobody heard him. On the 3rd time, he got off the table and went to find the nurse who was controlling this equipment. It turned out that what had happened was that there was a fault in the software that meant that if you carried out that specific sequence of instructions with that particular error and correction, and you did it fast enough, if you were quick enough at what you were doing to be able to do it in less than 8 seconds, you got the high beam without the metal plate in front. He died 4 months later of radiation overdose. 5 other people died from exactly the same problem occurring in different hospitals around the place before it was actually detected what the problem was and how it had been fixed. And finally, it, of course, got corrected. And I think, actually, the people who were making that particular equipment decided that they wanted to get out of medical electronics and went into control of nuclear power stations instead. Those sort of issues come up in computer systems. I mean, there were some particular bad practices in the way that software was designed, but the real point is they should not have been operating that system with the video link down. You have to recognize that systems will fail and that backups and protections and alternative ways of working are very important. Another example of telemedicine. There are transplant operations being carried out. A couple have been carried out, liver transplants, carried out in Bangalore with the anaesthetists who were monitoring the patient actually in the University of Chicago in America. So you've got the patient being operated on in India, and the people monitoring the patient and controlling the anaesthetics actually in Chicago, working over a telecommunications link. Because they were the skilled people and because they could bring real benefit to the success of those operations. And, of course, there was the risk of the communications line going down. And they had 2 alternative backup mechanisms for the communications line going down. And in one of the operations, the primary communications did in fact fail. And they switched over, in fact, to using Skype over the internet as their second form of backup. And then they had a 3rd voice-only form of backup that was backing that up. These things are happening already, and they are successful. But it's important to get a feeling for what can be done, and therefore what you want, and what can go wrong, and therefore how the whole system and service needs to be constructed in order to make the things that really matter as safe as they can be, whilst recognizing you're not going to get 100%. And different people have different attitudes to privacy. I mean, we carried out some surveys on a project I was on a few years ago, and were surprised to find that amongst the particular population of senior citizens that we were surveying, they were much less concerned about strangers knowing about their medical condition than they were having their family know that they were feeling ill. Because they didn't want to trouble or worry their children. It didn't matter to them whether some stranger could hack into this stuff on the internet, but they didn't want a monitoring system set up that would call their family if they had a fall, for example. And this sort of monitoring is becoming very easy to do. I don't know if any of you have used the Microsoft Xbox with the Kinect camera on top. The very, very clever software that enables that camera to recognize somebody moving in front of it and allow them to control what's going on the screen by waving their arms around, not like the Sony Wii with a controller in your hand, but completely just by gesturing. That clever software was developed by a team of researchers in Cambridge, the Microsoft Research Unit in Cambridge on the university campus. Developed the very clever software that does that. And they won a Royal Academy of Engineering prize on Monday evening as one of the best, cleverest bits of engineering that has been invented this year. And that system can be used. You could imagine a camera that is just sitting in the corner of a living room of sheltered accommodation, and it will detect somebody falling over because it will be able to recognize the unusual posture of somebody falling over and could immediately call somebody. It will be able to detect whether people are moving around in the normal way or whether there's something gone wrong with the way that they're moving, whether they're clearly not actually walking around in the same way as they usually do. And it could raise an alarm. But of course, the natural way to set something up like that is that it notifies the family. And then certainly the senior citizens in our sample wouldn't want one. That's too intrusive. So those sort of issues are the sort of things that I hope we will get into discussion about. And those are the sort of questions that I wanted to raise in your mind so that perhaps over lunch we can be having conversations about these sort of issues. Thank you for listening.